welcome to the session. Greeting of the day. In this session, we will see about, we are on the discussions of types of sensors. In those types, we have already covered potentiometer and the strain gauge measurement and displacement sensors. Now we will see about these capacitive sensors. What it is? These capacitive sensors are like a position change. It is here also the change occurs. Here also the displacement occurs. How? You see, we have two conductive plates. One conductive plate and two conductive plates. In the middle we have a direct medium or as insulator. When it is connected, these ends are connected to positive and this end is connected to the negative. When these two are connected to a bulb, it forms a power source that we see. The capacitor sensors is primarily used to measure the linear displacement for a millimeter to 100 of millimeters. That's okay. It comprises of three plates. The upper pair form here one capacitor. So I am talking about this pair. This pair forms one capacitor, and the lower pair is another capacitor. We will discuss. Another pair is the second capacitor, and then the middle one belongs to the dielectric movement. This one belongs to the dielectric movement. Whether it goes up or goes down, accordingly the changes occurs. You will come to know. The linear displacement might be takes place in two forms. How? This we are going to move. This is our. So this plate is our medium. Whether it may move up or down, which we name it as displacement x. That is what they have given. One of the plate is to move by the displacement so that the plate separation changes. It move up and down, so another plate becomes separation. It moved from the other. This change we have fixed one path and it is electrically connected and we know what voltage it gives. All things are already calibrated. But when the change in dielectric with a single middle medium takes place, it automatically the change in voltage occurs. That things can be measured. The circuit also I will show you. This is one point, right? And the second one, area of the overlap changes. When I am moving this plate up and down, it may. We know the first point, the displacement changes, or otherwise, if this moves in this direction, this we know this is one area. Now this direction move other side. What happens? Instead of being here, it moves to this direction. This part. It moves to this part. So this is calibrated two plates. It's already fixed there. But what happens when the area of the dielectric medium is moved on the other side? This portion becomes vacant and this portion becomes more filled. It means it's filled outside. Therefore, this change in voltage happens out of the calibration that we can measure. Okay? So this is how. Okay? A video which shows you how this works.
In laptop, ATM, tablet, mobile, we are using these touch screens in day-to-day life. In electric cars, bikes are also using these capacitors in day-to-day life too. The white red color we have seen in toy cars are all belongs to the capacitor. Before going to the capacitor, we should know something about what is charges first. There are positive charges and the negative charges that we know in general. When these two positive charges comes nearer, it repels actually. But the same thing when the one positive charges and one negative charges comes nearer, it attracts. This also we know in general. The force between these two charges are also known as electrostatic force. But the field between these two charges are known as electrostatic field. These two plays a major role in the capacitor. In a capacitor, we have two plates and an insulator between them. When these two conducting plates are connected through a battery, these positive charges are generated in the positive side of the battery and the negative charges are generated in the negative side of the battery. Therefore, in this situation, this positive will attract the negative, but the insulator between these conducting plates will not allow to flow directly and interchange the charges directly. Therefore, but remember, there will be electric field between these conducting plates. Now let us consider two magnets and insulator between them. When these two magnets are brought together, this magnet will be attracted and joined along with the insulator. Even if these magnets are not directly joined, there will be a force between them in this magnet. Now, simultaneously, if we remove the battery in these conducting plates, the charges will be there between these plates. If we connect the two plates to the bulb, what happens? The charges will flow and produce the current and so bulb will on. The mobile also works on the simple same principle. In this mobile, we have one glass plate, two conducting plates, and one insulating sheet between them. As like we have seen in the capacitor, one insulator is between the two conducting plates. That we understand from the given diagram at the side. Now what we can do here, what happens as like capacitor process, the upper sheet will have a positive charge. As like the capacitor process, the upper sheet will have a positive charge and the lower sheet will have a negative charge and a electric field between it. This electric field will be measured by the processor, which is already calibrated. When a positive charge person touches the screen, a upper sheet which contains the positive charge will repel. Therefore, it creates some changes or disturbance in the electric field, which is monitored by the processor, and this processor will understand this what happening and it opens that the corresponding app on the as the preset program and opens the app. Like this only this capacitor sensor works. But our old phones are not based upon this type of capacitance sensor. It is based upon resistive touch screen method. In this also we have two conducting sheets and one insulating sheet between it. When the force is applied over the screen, these two conducting sheets will come in contact and closes the circuit. This will be sensed by the processor and gives the output. These are used usually in the supermarkets and ATM machines. This helps in electric cars and bikes also. We want to know the difference between the battery and the capacitor first. We can take one example for that. Let we have a 200 gram of explosives. We have 200 grams of explosives. We create one long run explosive and we create one immediate blasting explosive. This long run explosive is known as a battery and this blaster is known as a capacitor. We understand. When these two are fired at the same time, this immediate blaster will explode at all at one blast, and this long run explosive will crack slowly and steadily. Likewise, we understand this battery can also able to give a uniform for a longer time and supply a good. But this capacitor will produce it all power at a one single blast. This battery will give uniform and longer time supply, but this capacitor will produce it all power at a one single blast. That we understand. Now you understand the difference between battery and the capacitor first. Let we see how this capacitor are used in the electric cars or bike. Whenever we want to start a car or to go at a top speed in a second, what we do? This electric car motor will need a high power at a shorter time. To go at the top speed in a second, we need an electric motor, we need a high power at a shorter time. The available battery only can able to give, if it gives it a, it will drain, repair and dead. The available battery only cannot able to give this high speed, therefore it will drain, repair and dead. In this situation, we use the capacitor. This will give a more power at a shorter time. Mileage will be maintained by the battery. A supercapacitor is used in this electric car are more powerful, and these are 100 times powerful than that of the normal battery. So therefore we use the supercapacitor and the cars and the bikes to make the speed. Also we can able to charge this in 10 seconds, and we can able to use this in 10 lakh times. We can able to charge in 10 seconds and we can able to use in the 10 lakh times. If we use this supercharger, we can able to reach a 60 kilometer speed in 1.9 second itself.
From the video, we have seen how this connection happens. So as the central plate moves near to the top plate or bottom plate, this is how we have mentioned already. When the top plate are maybe due to movement in the workpiece, which displacement is to be measured. The separation between the plates changes. So what I have discussed here, this point, it has been given here, clearly here. Okay? So number one option, this is the plate move changes at D. Right? When this distance may change, then also the calibrated voltage difference will come. Or otherwise, the overlapping two conductive plates will change like this. Then also the calibrated voltage changes. That is also displacement. And here the radiative movement they are showing here. The radiative movement from here, it moves from this direction. Right? When the C1 and C2 are connected to the voltage circuit, I am repeating, this is what? Voltage circuit, then the resulting out of balance voltage, the voltage circuit is connected, it is calibrated, then out of balance voltage would be proportional to the displacement. Proportional to the displacement. Which one? This one. Proportional to this displacement. How much it is differs. Where we can use this? Let us consider an example of making a water level increasing. So the dielectric medium can be the air, the vacant air. We have two conductive material, air is in between, and we have calibrated this one. Now I am keeping this setup near to the water tank. Here the electric field is generated. We have seen the electric field due to this attracting and repulsive force. The electric field is generated in between. You see. This electric field changes, what happens? This electric field changes, a fixed electric field will be changed when the water level is increasing. The obstacle comes, the electric field, measured electric field will be changed. Therefore, those change in electric field can be measured in terms of change in the displacement, change in the position, or change in the water level, whatever it is. So what I have given here, the displacement changes. As the displacement changes, obviously the capacitor increases. See, two plates are there, a fixed plate and a movable plate. This distance to be calibrated already. This distance, it means this distance. This distance is already there. Now it is changing. When the out of changing happens from the fixed point, it is measured. Right? So here I like to play a video to understand it better. See, here we have two plates connected to the power supply. From the power supply, the electric medium is direct medium is air. Maybe to our case, to measure the water level, it is air. Okay. So now, listen carefully. Here the setup. Here the setup. What I am doing. A capacitor sensor. Sorry. A capacitive sensor is kept here. This is the capacitive sensor. Inside what are there? Two conductive material. Two conductive materials are there. So this conductive material connected to the power supply. This is closed. Now we are giving the supply. What happens there? Due to those conductive materials, the electric field is generated here in between this gap where the dielectric medium is air. As it is the air, there is no disturbance we can keep near to any object. That air electric field will be disturbed. See, now there is an electric field generated. There is an electric field generated here, and we have kept these capacitive sensors nearer to it, to the tank. So when the tank is empty, this air electric field is not disturbed. It will be as it is. The flow of calibrated supply will be there. What amount is there, will be as it is. But when this liquid level increases, or we consider a car, when the car level comes very nearer, the rear cameras or capacitive sensors we are having, when the level is there, when it comes nearer, it keeps alarm. Right? Or otherwise, when object is kept a constant, when a thief cross over, when in the industry, when the object cross over, the electric field is disturbed, then obviously it is identified. Like alarm you can use, a position alarm. For the displacement, the change we are using anywhere, for identity we can use this. So now the electric field is not disturbed, we are getting as usual what it is. But when the water field is increased, see, here the electric field is disturbed. If it is disturbed, there will be some oscillation in this electric circuits. Therefore, these changes are directly measured there. The change in displacements or change in the positions or filling of the water, whatever it is. When the electric field is disturbed, it is measured. Maybe identity or maybe a change. So again, in the industrial process, I am using the same this capacitor sensors to measure the movement. I told you the level increases. Here the object movement is crossed, maybe a thief, maybe a bottle, maybe wood, metal or non-metal. You see this point, the light is blinking. In such a way, we can able to make these corrections, which will be more useful to identify the movement or change or displacement, whatever it is. So again one more content I am taking here, which is we have already seen there also, the mobile phone operation. Here on the screen we have two conductive plates, that side and this side, and we are operating from here and at the one end. So this is our capacitive sensor, and due to this electrical circuits, here the dielectric medium we are using, a fluid dielectric medium, and when it is operated, The touching operation will come and close the circuits. By using this, we can able to operate the mobile also. So few examples I have given here for your identity. Right? So now some of the applications what we have seen that I am telling here. What I have seen that I am telling you. See, the metals or non-metals can be there. Metals or non-metals, whatever it is. We have seen the industrial scope that a wood object is moving, a plastic bottle is moving, any metal object that the field to be disturbed, that's it. Then it is measured. Okay? A metal or non-metals on mobile touch screens. So now only we have seen one example of video, mobile touch screens, the car reverse parking, or we can tell the mobile proximity sensors as we keep it closer to the phone. We are keeping the phone here, how it is until after the call attended that the field activated. When we are keeping our phone very nearer to our ear, this distance maintained or differs. Then automatically the screen goes black. When we move from our hands, it comes up. So such types of operations they are doing through this capacitive sensors. Right. So one more are there. We can use the same capacitive sensors in many fields. As like I told you earlier, the water level can be a coolant, right? Can be water, can be salt water may be a petrol. So this method is they are using in the car or bike for filling up the petrol, the tank. What how they are doing? They are putting inside and they are keep on standing. How it fills? When the water level increasing here, it reaches this position, it automatically shuts off. Then the tank filled, they are moving out. In that petrol putting gun, they have attached this sensor, capacitive sensor. There it works. Few points we see. Feeding up a hooper level, a monitoring process, right? So another the small vessel pumps, any water level, the pumps belongs to waters. Grease and oil level managements. The thing, it is nothing, a position. Increase or decrease, it is a displacement, moves or not moves. It's a constant or not constant. Field disturbed or rectified, not disturbed. That's a final point we need. So it is used to detect the presence of certain components such as glues, etc. A measure of shape errors. This object should be come in this way. I have a sensor here. When it moves beyond the limit, it measures. I have a sensor here. The object should measure from here. The rays are here. When the object comes additionally in this height, automatically it is disturbed. Right? So to analyze and optimize the rotation of the spindles, to test and assemble the parts of uniformity, that is nothing but a shape or a constant movement, a gap, a thickness, everything we can able to do it here. So for this, what will be the advantages and the disadvantages we can use here? See, as I told you, it is a very fixed one, and also it's a bit less expensive, very accurate, and no moving parts. Object it is kept here, that's it, and no moving parts are there. Therefore, we can use wisely. But there is two problems are there. What it to be every time? Any object to be calibrated, that we know. Any object to be calibrated. But here, the electric field where the jet is generated will be very harmful. That's to be we have to keep in mind. So invoice, a harmful electric field will form. So this we have to keep in mind at the workout. So such cases may occur. So what I have told you, the advantage is very compact, then less expensive, a simple approximity of two conducting materials, we have to keep, and then we have to connect electric field circuits and we have to keep inside. That's it. The water level increase here outside is detected. It's already calibrated, here outside is detected. But when it reaches the highest point, then it ends. then it ends. So keep remember those points of advantages, disadvantages, which will be more useful. So in these cases, I would like to go for the summary of this session. In this summary, what we have done, is we have talked about the types of sensors. I repeat, types of sensors. In this, we have discussed about the position, the displacement, right? Like potentiometer, then the strain gauge, and then also we have recently we have seen the capacitive sensors. Right. Another remaining velocity sensors are there, light sensors are there. Remaining sensors we have to come up in the upcoming sessions. Remaining parts we will see in the next session. Thank you.